welcome to HSFC Electronics. Today's video we are going to see some questions from the 2019 Technical Assistant Examination. This is a part 4 video of Technical Assistant previous year questions of 2019. There are 3 parts of 2019 solution. This is a 4th part. Okay, so in this video I have included some difficult questions comparatively to the part 1, part 2 and part 3. Okay, so let us see what is the first question. So the first question is find the resistance between A and B. Now, how to find the equivalent resistance between these two terminals which are A and B? So this is actually a bridge circuit, right? So how to solve this bridge circuit? Okay, so while teaching how to solve this question, I'll try to convey you how to do the delta to Y conversion. Okay, so we are going to study first how to convert delta circuit to Y circuit. Okay, what is delta and what is Y? So if you see the top triangle of this circuit, so this consists of a top triangle and a bottom circuit or a bottom triangle. These two combines to form a bridge. So if you take this portion, that is this much, this looks like a delta connection. Now this delta connection, okay, let this be RA, RB and RC, can be converted into a Y form. Y means connecting the resistors like this. Okay. So here if you see how to form a Y connection, there is one branch here and one branch will come here. Okay. I'll draw it according to this delta. So there is one branch here, one branch going here or one branch going here. Okay, so inside if you draw it, the Y, it will come like this. So the inner 3 resistors form a Y connection. The outer 3 resistors form a delta connection. So the summary is that if you have a delta connected network, you can replace it as a Y network provided that these value of resistors, let this be R1, R2 and R3. Okay, the value of this resistor I have taken as R1, this resistor I have taken as R2 and this resistor I have taken as R3. Okay, so I'm going to draw it here. This is R1, this is R2 and this is R3. Now the value of R1, R2 and R3 will be like this. R1 is equal to, if you see R1 is in between RA and RB. So R1 is equal to RA, RB by RA plus RB plus RC, the total or the 3 resistors. Okay, so that is R1 here. Now R2 will be equal to, R2 is equal to, R2 is in between RB and RC. So RB, RC by again RA plus RB plus RC. Okay. Similarly, you can write the value of R3, which is the 3rd resistor in the Y network, as R3 is in between RA and RC. So RA, RC by RA plus RB plus RC. So this is how you can form a delta to Y conversion. So if you have a delta, you can convert it as Y, provided the value of the resistors in Y will vary like this. R1, R2 and R3 will be vary like this. Now in this question, I am going to apply the delta to Y conversion and try to solve the network to find the equivalent resistance. Let us see how. Okay. So first I am going to take my delta, that is, there is a, I'll draw it a little bigger. Okay. So this is my delta, which is the top portion of my circuit. This is 10 ohm, this is 40 and this is 50. Now, as per the delta to Y conversion rule, I can have a Y here. So if you see, this look like a Y, right? See, this is a Y. That's why it is called a Y conversion or a Y network or a Y connection. Okay, how will be the value of this resistor? I'm not going to write a general equation, I will write it directly. So this resistor is in between 10 and 40, right? So the value of this resistor will be equal to 40 into 10 by the total value, it is 10 plus 50 plus 40. You know that 50 plus 40 is 90 plus 10 is 100. So if the delta to Y conversion is to be applied, the value of the resistors will be easy to solve to have this conversion. Okay, so 40 into 10 by 100, that is equal to 4, right? So this value is 4 ohm. All the values are in ohm. Okay, now consider this resistor. It is in between 50 and 40. So 50 into 40 by total value is again 100. So it is 5 into 4, which is equal to 20. It is very simple to solve if you practice. Next, this is 10 and 50. So 10 into 50 by 100. So it is 5. Write it correctly, 5. Now I have converted by outer connection, that is delta connection, and replaced it with a Y connection. Okay, so I'm going to remove the delta first because I've obtained my Y. I've removed the delta here also. So this is my Y connection now, right? So I've changed the top portion of the circuit or the connection like this. Now this is my A, and there are two other resistors, right, which is having value 10 and 25, and this is my B, right? So now this is my A and this is my B. Okay, I'll write it here. Okay, so this is my B and this is my A. This value is 25. Now I need to find this, the equivalent resistance of this. Okay, so how is the connection of 5 and 25 coming? It is a series connection, very simply, right? This is in a series connection. So 25 plus 5 is 30. So it is a 30 ohm. I can replace it as a 30. 30 ohm. Again, 20 plus 10 is again series connection. See, it is a series connection. So total resistance is again 30. So this is again a 30. Now if you see this two 30s, it is in which form? Parallel form. See, the terminals are connected together, the top and the bottom terminal. So it is a parallel connection. So 30 and 30 connected in parallel will be equivalent, having 30 by 2, which is equal to 15, right? So replace these two 30s with a single 50. Now this 15 and this 4 is in which connection? Series connection. So 15 plus 4 is equal to 19 ohm is the value of your equivalent resistance. Now if you try to solve this question without doing the delta conversion, that is delta to Y conversion, I have tried in a number of ways, but I have not obtained the value is correct, which is a 19 ohm. But if you know some other way to do it, you can please tell me in the comment section. Okay, anyway, the correct answer for this question is option B, which is 19 ohm. I hope you understood with this question, that is how to do the delta to Y conversion. Okay, my aim was to convey you that concept also. I hope it is conveyed now. So we can do the delta to Y conversion to simplify such bridge networks, which is little complex to solve. Okay, so let us see what is the next question. The next question is this. In an amplitude modulated system, if the total power is 600 watt and the power of carry is 400 watt, then the modulation index is dash. So in this question, they are asking the modulation index directly in terms of the power. So what is the equation to find the value of modulation index in terms of power? The relation is like this. PT, which is the total power of the system, is equal to PC, which is a carrier power, into 1 plus mu square by 2. Okay. So generally we calculate the modulation index in terms of the voltages of the modulating signal and the carrier. Okay, but here you can also find it in terms of the power, which is equal to PT is equal to PC into 1 plus mu square by 2. In this question, they have given both the value of PT and PC. We need to find the value of mu. Mu is a modulation index or the modulating index. Okay, so PT is 600 is equal to PC is 400 into 1 plus mu square by 2. Okay, 600 by 400 can be written as a 3 by 2, right? So 3 by 2 is equal to 1 plus mu square by 2. Again, 1 plus mu square by 2, if you take this 1 to this side is minus 1. 3 by 2 minus 1 by 2, 1 is 1 by 2. 1 by 2 is equal to mu square by 2. So 2 and 2 will get cancelled. The value of mu is equal to 1. Mu square is 1, so mu equal to 1. Okay. So the value of your modulating index is equal to, here it is given as 1.00. Don't get confused with it. It is a 1. Okay. So the correct answer for this question is option D, which is 1. Modulation index is 1. Next question. Minimum number of flip-flops required for modulus 15 counters dash. So there can come a lot of questions based on this. That is, they'll be giving some modulo values and you need to find the value of the number of flip-flop required. So the general equation is, if it is an n modulo counter, then n should be less than 2 raised to n. This is the equation to do this. Okay, that is n should be less than 2 raised to n, where n is the modulus value. Here it is a 15, modulus 15 counter, and 2 raised to n is the, small n is the number of flip-flops needed. Okay, so if you are somebody who is preparing for technical assistant, I request you to watch this video till the end, because I am introducing little new concepts with each of the question. Okay, so this is a general equation. N should be less than 2 raised to n. Here, see, it is a modulus 15 counter, right? So the value of capital N is 15. And you have to think about the n value, small n, or the number of flip-flop. Okay, let us start with 1. If you take the value of flip-flops, the number of flip-flop as 1, then it is 2 raised to 1. Is this condition satisfied? No. Then take 2. 2 raised to 2 is 4. Again, not satisfied. 2 raised to 3 is 8. Not satisfied. Then take 2 raised to 4. 2 raised to 4 is 16. Yes, 16 is greater than 15. Or this condition is satisfied. Now, the value of n is equal to 4 will get. Okay. So the condition is your modulus value should be less than the 2 raised to number of flip-flops in general. Okay. So the value of n is 4 here. Let us try to do another example. Consider it is a modulus 3 counter. 3. Modulus 3 counter means it counts 0, 0, 0, 1, 1, 0 and 1, 1. Right. So here itself it is clear that the number of bits, the number of flip-flops needed is 2. That is, for each bit you need 1 flip-flop. So let us not think like this. Let us consider the value from 0. It is not possible, it is a 1. 2 raised to 1. No. 2 raised to 2 is 4. Yes. 3 is less than 4. So you need how many number of flip-flops? That is 2 flip-flops. So likewise you have to think. Okay. So the number of flip-flops needed is equal to, or the modulus value n should be less than 2 raised to number of flip-flops. Okay. So this is the condition. I hope this is clear. Sorry, I forgot to tell the answer of the question. The correct answer is option C, which is 4. That is, you need 4 flip-flops to do a modulus 15 counter. Okay. Let us see the next question. A power amplifier delivers 25 watt AC power to a 4 ohm speaker load. If the DC input power is 40 watt, what is the efficiency of the amplifier? So the efficiency equation, eta is equal to PAC, which will be your output power, by P DC, which will be your input power, into 100. Since the efficiency is calculated in percentage, it is into 100. Now, the value of AC power is given, the value of input DC power is given. So, you can directly substitute and find the value of the efficiency. So, this is the equation to find the efficiency of a amplifier. Okay, so what is the value of AC power? It is 25 watts, right? So, 25. What is the value of DC input power, which is 40. So, cancel this, and 25 by 4 is 6.25 into 10 is 62.5 will be your efficiency, and it is 62.5%. Simple question, right? So, you should know the equation, that is efficiency eta equal to PAC or AC power by input DC power into 100. Okay, let us try to do the next question. A transformer has 350 primary turns, primary winding number is 350, and 1050 secondary turns. So, the number of primary windings and secondary windings is given. The primary winding is connected to 230 volt 50 hertz voltage, and the frequency is given of the primary input. The induced EMF in secondary is dash. Okay, so the equation to find the induced EMF or the relation between the voltage and the number of turns is given by Vp, that is a primary voltage, by Vs, which is a secondary voltage, is equal to Np by Ns. Right. So, Vp is the voltage applied to primary, Vs is the voltage induced in the secondary, Np is the number of coils or the turns in the primary winding, Ns is the number of turns in the or the number of windings in the secondary coil. Okay, so all these terms you know. What is the value of your primary coil numbers or turns is 350. Then the secondary is 1050. The value of your primary voltage applied is 230 volt. Okay, so in order to find this, cross multiply and find the value of Vs. So Vs will be equal to into 1050 by 350. This will be your Vs. Okay, so if you solve this, you will get the value as 690 volt. Okay, so 690 volt and the frequency will be the same. So 690 volt 50 hertz is the value of your secondary induced EMF. Okay, so the correct answer is 230 volt 50 hertz. Okay, so the correct option is option A, which is 690 volt and 50 hertz. And for this question, the correct answer was option C, 62.5%. Question is, how many number of bits needed to implement a microprocessor having 115 instructions? Okay, so the options given are A5, B16, C7 and B8. So here if there is n number of instructions, then the relation is n should be less than 2 raised to number of bits. Okay, so here n is 115. So we'll try with various number of values of n. Okay, we know that the value of 2 raised to 4 is 16, 2 raised to 5 is 32, 2 raised to 6 is 32 into 2 is 64, 2 raised to 7 is 64 into 2, 4 2s are 8, 6 2s are 12, 128. Okay, so the value of 2 raised to 7 is 128. So which is greater than 115, or in reverse 115 is less than 2 raised to 7. Right. So how many bits is required? We need 7 bits to create or implement this microprocessor, which is having 115 instructions. Okay, so the correct answer will be option C, which is 7. Okay, so these are some questions which I have included in this video. I have tried to include some questions which we have not discussed till this. Okay, so I hope this video was useful. We'll do more videos on various questions from previous years, and also I'm receiving a lot of requests to do subject-wise videos. We'll be doing that also side by side. And also, I'm receiving requests to do videos to about the cutoff marks and the subject syllabus for ISRO Technical Assistant and for Scientist post. We'll be doing or uploading the videos very soon. Okay, so I hope this video was useful. If yes, please do give it a thumbs up and also share this video with all your friends. If you want more videos, please do subscribe to the channel. Thank you.